So welcome to the test-driven development course. So why test-driven development? Well, a lot of companies these days ask for test-driven experience for any prospective engineers. So this doesn't mean that you've actually written tests before or that you've written code and then put in your tests afterwards. It means you've actually used the test-driven development process. So the test-driven development process is a way to actually solve a problem in a systematic way. This is what potential employers want to see, whether you can take a specification, understand it, and actually go ahead and solve that problem. Using the test-driven development process, you actually produce clean code as a side effect. And when you have clean code, it actually communicates what the program is actually doing. And the next engineer might be you in a few weeks or a few months' time. And you don't want to be starting again trying to figure out what the code is doing. It really should communicate, and the unit test should help in the communication of what the program actually does. The test-driven development technique is where you write a failing test first, you write code to pass the failing test, and then you refactor to remove any duplication. This is further redefined into the 3 laws of test-driven development. The first law is you're not allowed to write production code unless it is to make a failing unit test pass. You are not allowed to write any more of a unit test than is sufficient to fail, and not compiling is failing. You are not allowed to write more production code than is sufficient to pass the one failing unit test. So why fail first? Well, it's a good way to see your regression tests. So if you add some code, you want to make sure that nothing breaks. And also when you write a test, you don't want to see any false positives. So if you write a test and everything passes, then that could raise some questions. Either you're not testing the right thing, or that test scenario has been covered with something else. It also makes you think about what code it is that you're going to write. And another thing is your code will be testable from the outset because you'll be writing your tests first. What you don't want is to hack away writing a function or a set of functions and then having to put tests in afterwards, especially if you've done some sort of Ajax or database call. You don't want to have to refactor any of the code that you've written to actually fit in with tests. And there's another part to this technique. Uncle Bob put it best when he said, as the tests get more specific, the production code gets more generic. What that means is when you first start off, you want to hard code values. And as you progress, you turn those hard-coded values into variables. We'll see more of that later. The application of test-driven development is where you break a problem into small achievable steps. For us, we have a goal to build a game of life. So this will be broken down into small achievable chunks. And then after you've selected these chunks, then you break that down further into what your tests will be. So you break down the test and list the tests that you need to achieve for that particular function to be considered done. So as Ken Beck says, start small or not at all. So you write the simplest test and then you write the simplest code to pass that test. And as you go along, stub or mock any dependencies. Again, like we mentioned before, you might be testing an API endpoint or some sort of database query. So there's tools out there where you can actually mock, which is insert something that has the same or similar functionality, but it's actually not the real thing. There's a lot of testing frameworks out there, especially in JavaScript, but they all consist of some or all of these tools. One is a testing harness. So the testing harness is the orchestrator of the tests. So that consists of assertion libraries, which is where you make your statements of truthiness or falsiness. So essentially this comes down to a Boolean value, assert X. So that means, is this true? There's reporting libraries. So when you see on your console the rendered out report of the tests, you can have different templates, or this could be used in continuous integration. And also code coverage is a handy tool. Not every library includes that. You've got packages such as Istanbul which have that functionality. For us, we'll be using Jest because it covers everything above and more. It comes with built-in mocks for the browser especially, spies, the documentation's really good, and you can test browser environments or server-side environments. For our task, we're not interested in focusing on a particular style of programming such as functional. We're not intending to be functional pure. We're not going to do any object-oriented programming. We're simply going to use this example as a technical test. So say we're going for an interview at a company and they've given us this task to do and they want to see a test-driven developed product.